Rightio, just catching up on a few questions we've got here in the collaboration space. F of x equals 2 to the power of x over x. That's what essentially we've got there. We usually write it this way, but it's the same thing and we're all happy with that. Okay, 2 to the power of x divided by x. It's a bit of an unusual one, isn't it? Not what we're used to seeing. That's because it's disappearing from there, but this is going to be in your calculator section. Calculator. I'm getting there eventually. So this is not a standard sort of one, but let's see how we go. Does the function have any axis-intercepts? Well, to find the y-intercept, what do? Let x equal 0. So f of 0, I'm going to have 2 to the power of 0, which is of course 1. Oh, but I'm going to divide by 0. What does that mean? No good, is it? Dividing by 0, undefined. So it's not going to work. We're not going to have an intercept on the y-axis because x can't equal 0. It would make the function undefined. What about an x-intercept? How do I find the x-intercept? Let y equal 0. Okay, well that should be easy enough. So I'm going to have 0 equals 2 to the power of x divided by x. I can multiply through by x. I know that x can't equal 0, so that's easy enough. 0 equals 2 to the power of x. Oh, got a problem again, don't we? If I have x equaling 0, well 2 to the power of 0 is 1. We know that much. A number bigger than 1, well we're going to be finding powers of 2. So it's going to be a value bigger than 1. What about if x is a negative value? 2 to the negative power, that would be 1 over 2 to a power. It's getting closer and closer to 0, but it's never actually equal 0, is it? So it looks like we're going to have an asymptote there, and you can see in part B, find the equations of the asymptotes. Well, the vertical asymptote we got from this first bit, if it's undefined when x equals 0, the vertical asymptote will just be x equals 0. The horizontal asymptote, if y is never allowed to equal 0, is that indeed a horizontal asymptote? Well, the good point about this one is, of course, that this is your calculator question. So what they're actually wanting you to do is go ahead and get your calculator out and have a look at what to do. So let me just pause while I get my calculator out and we'll come back. So we've got the calculator here. Let's turn the menu on. I want to graph something, so I go to the graph function. 2 to the power of x divided by x. So here we go. 2 to the power of x. I should probably make sure I get that right and just put it all in brackets to make sure I take the whole thing and then divide it by x. What does that give us when we draw it? Yes, look, asymptotes, just as we wanted. Isn't that good? Very good. Find any turning points of the function. Now, we haven't actually done the calculus to find turning points of this yet because you don't know about the derivative of 2 to the power of x. We could go ahead and do that and find where the gradient was 0. But if we're doing it and it's a calculator question, Shift G solve, what's the minimum value? And there's one local minimum, and you can see it's at 1.442695045. Not very exact, is it? But you get the idea. And the y value, the minimum at that point, the local minimum, is 1.88. Clearly, it's not the minimum overall. Why not? Because as we keep going down here, obviously that looks like it's going to continue going on down there. And then sketch it for the domain -4 to 4. So set up our viewing window. I want to go from -4 as the minimum value of x up to 4. And now we exit. It will show it to us. There we go. That's the function there. 2 to the power of x. What is 2 to the power of x? Oh, it's a curve that increases like that. And then I'm dividing it by x. And that's what you end up with. I hope that helps a little bit. There we are. We're done. Catch you in the next one. Bye.